Example 2, solve by completing the square. Notice in this quadratic equation is a little bit different from the previous one solved. In this quadratic equation, the coefficient of the x squared term is some number other than 1. So recall when the coefficient, which we call a, is not 1, step 1 would be to divide both sides of the equation by a. In other words, divide both sides of the equation by 2. From that point on, you will solve by completing the square the same as you did in the previous example. In other words, just follow the process and procedures for completing the square. So recall, what you do to one, you must do to all. So notice that all terms were divided by 2. Once you clean that up, because if you look at the first term, the 2's will cancel out and leave you with the x squared term. For the second term, you have negative 4 divided by positive 2. That's going to give you negative 2x. The last term, you're going to have negative 3 halves. And on the right side, remember when 0 on top, that equals 0. So this is now your equation. Your next step then will be to get your your x terms on the side by themselves on the left side, and your constant term will go to the right side. So to get the constant term on the right side, the first thing I will need to do is to add 3 halves to each side. And now that we have the equation in this form, we're ready to start completing the square process. So we're going to look at the second term, which in this case is a 2. And we're going to look at the 2 and say, what's half of 2? Half of 2 is 1. 1 squared equals 1. So we're going to add 1 to each side of the equation. Okay, our next step is we're going to go ahead and factor the left side of the equation, which is a perfect square trinomial. So as you can see, that's going to factor into x minus 1 squared. On the right side, you have a whole number and a fraction. We're going to combine those together by multiplying the whole number times the denominator plus the numerator, which is going to give us 5 halves. So we're going to go ahead and bring that down. Next, because the equation is now in the form where you have your square term on one side and your constant on the other, we can finish this equation by applying the square root property, which states you're going to take the square root of both sides. Now on the left side of the equation, that process of having a squared number and then taking the square root of it is a reverse process that cancels each other out, and it allows you to bring down the x minus 1 alone. On the right side, we have a radical, and recall when you take the square root there that is going to equal plus or minus that constant. So plus or minus square root of 5 over 2, or plus or minus radical 5 over 2. Now the next step to solving for x in this equation is to add 1 to each side. And x equals 1 plus or minus square root of 5 over 2. Now we would be done with this problem if the radical was simplified. Recall that if a radical contains a fraction, then the radical is not simplified. And the reason it's not simplified is because you have this fraction, the whole entire fraction is under the radical symbol. That is the same as saying square root of 5 over square root of 2. And the problem is that you cannot have a radical in the denominator. So we have to use a process called rationalization, where we find the smallest root that we can multiply the denominator with to produce a perfect square. And that would be square root of 2, because the square root of 2 times square root of 2 equals square root of 4, which will equal 2. Now the problem is, or it's not a problem, but remember that if we multiply the bottom of the fraction times the square root of 2, we have to multiply the top as well. So in our numerator, I'm going to have square root of 5 times square root of 2, which is square root of 10. And at the bottom, remember, it equals 2 because square root of 4 equals 2. So now we've simplified it. X equals 1 plus or minus square root of 10 over 2. And actually that answer should be good enough. However, in some forms or textbooks, or some instructors may require you to go even further with simplifying that. If so, we can simplify it by rewriting 1 as a fraction. Recall that any number over itself equals 1. So we can rewrite 1 as 2 over 2, which means the same thing as 1. And in that form, notice that the bottom, they have a common denominator of 2. And on top, we have a numerator of 2 plus or minus square root of 10. So you can write it as 2 plus or minus square root of 10 all over 2. Okay, that's it for this lesson. Thank you for watching math videos on PowerPoint. If you found this video to be helpful, please like, share, and subscribe.